Students, welcome to my YouTube channels. Today our subject is strength of material that mechanical and civil students will study in the second year. So this unit 1 composite sections problem. So before also already theorem and problems already we uploaded and my YouTube channels you will see the lot of subject also. Engineering mechanics will be there, thermal engineering will be there, mathematics will be there, math 3 and all. And now strength of materials also I given. So before also some few videos is there, so there all concept, theorem, everything is we discuss. So this problems also belongs to the composite sections problem. So how we'll solve these questions we'll see now. Very simple steps we'll solve. So what is the given here? Composite bar the given, two material, three bar is there, two copper bar, one steel bar. So rigidly fixed this. So what is rigidly fixed means either compression or tensile. All suppose compression na copper bar steel bar compressions will be equal. Tensile na tension will be equal. So this is the concept will be there. So what is the given here? A steel rod and two copper rod together support a 370 kilonewton as shown in the figures the given. Cross sectional area the given. Cross sectional area for steel. Cross sectional area for the steel. So AS symbol, cross sectional area of the steel. So exams if you write now, you have to write area of the steel. Area of the steel or cross sectional area of the steel, cross sectional area of the copper. I wrote here symbols only. But once you are writing in the exam, you have to write the full name. Area of the cross section of steel symbol AS equal to 2500 given. Similarly, area of the copper they given 1600. But here two bar is there, two copper bar is there. So area we multiply 2 into 1600. This you have to careful. Sometimes two bar will be there na area, whatever the area will be there, what that will take. So here two bar is there copper, so I taken area 2 times. Length of the copper rod or copper bar, they given 15 centimeters. So we convert it into meter because all other dimensions they given area, Young modulus and on mm. So this also we converted into mm. So length of the steel. So length of the steel how much? So see this 15 plus 10. So 250, 25 centimeter, 250 mm. So these are the given data. Then also what is there? Steel Young modulus or modulus of elasticity, steel and copper they given. Okay. So now we'll solve this question. So now you see, if suppose load will be there in the down, that means strain will be same, elongations will be same. But here what is there? 370 kilonewtons bar weight will be there. So this contractions will be there. So that means what will have decrease of the length of the copper equal to decrease of the length of the steel. So first point, what will be there? First condition, decrease in length of the steel. Decrease of the length of steel rod the given steel rod equal to decrease of the length of the copper rods. Decrease in length of the copper rod, first condition. So what is decrease in the length? Suppose here delta L will be there. Now what is PL by AE? This is the decrease in length or increase in length. So P by A here, this P by A is nothing but stress length into Young modulus. So decrease in length of the steel, suppose you will write now, what is symbols? If we will take delta L equal to delta L of steel. So as if you will write or delta, okay, write delta L is steel. So what will write here? Formula will be S by ES into LS. If you write decrease in length of copper, so decrease in length of Cu symbols I am taking na sigma Cu by ECU into LCU. This we can write here. So now both will be equal according to the condition. Composite bar, what will happen if they will reductions will be length means steel and copper both length will reduce. So what we'll write here? That implies sigma s es. Es, what is value they given? 2 into 10 to the power 5 into length, how much given? LS length given, steel length 250 equal to, both will be equal, so this equal to this we can write here. That means we can write here delta LS equal to delta LCU. This we wrote here. So now we are going to write. So copper by ECU now 1 into 10 power 5 into length. Copper length how much given? Copper length will be 150. 150. So what we'll get here? We'll get the stress. So we still a stress of copper relations will get here. So that implies if we'll solve this stress, this copper relations will come. Already we solved. We will see the what is the relations coming. 1.2 stress Cu. If we will see this relations here, that relations will get here. So this first relations we got. Now second, what is the steel pressure and this? So total pressure of the steel we can write like this, load of the steel. So second case what we can write? Load in steel plus load in copper rod, load in steel rod, you can write this also. Load in steel rod, load in steel rod plus load in copper rod equal to total load. Total load. What is the total load? Okay, total load I'll write. Okay. So what is this one they given? 370 into 10 power 3 Newton. Now load. What is the stress formula is equal to? Internal force per unit area. So we need the load. So P equal to what is stress into area. What is this one? Stress into area. So what we'll write here? Stress of the steel into area of the steel plus stress of the copper into area of the copper equal to this is the length here, 370 into 10 power 3. Total, not length, total load. Okay, now we'll substitute this value and we'll solve. So sigma s, that means stress of the steel how much? 1.2, that implies 1.2 Cu, and area of the steel they given here what is 2500. Then copper, stress in the copper into area of the Cu they given how much? 2 into, so 3200 equal to how much? 370 into 10 power 3 we got. So see this numerical value, this and this. If we'll solve this, sigma Cu will come. So this will come denominator. So 370 into 10 power 3. And this part if we'll solve, already we solved and kept here. So 6200. It will come 6200. So this if we'll solve now, stress of the copper you will get 59.67. So if we'll solve this, 59.67 Newton per mm square. This we got the stress of the 59.67, correct. So stress of the copper rod. Okay, now they're asking only what they're asking. Find the stresses in the rod. Only stresses they're asking. So next, what will be there? Suppose this give equations number 1. Substitute sigma Cu, that is stress of copper, in equations 1. So what is there? Sigma steel or stress of the steel 1.2 into 59.67. This value will come 71.601 Newton per mm square. So this you will get the another answer. So this problems, what is the answers we are getting? These answers we are getting. So look here. If you'll see the book, if you'll go the solve, if you'll take the help from the books, you'll see the 1.5 page or 2 page problems will be there. So main things what will be there? Given data collect, write this all the values. Given what will be the conditions, always will be there. Two conditions decrease because load is given in the upper tube. So that means this will the contractions will be there. So due to this, what is decrease in length of the steel rod equal to decrease in length of the copper rod. So what is decrease in length? PL by AI. So P by A we taken stress. So from this formula we got the this, you always remember, see here, decrease in length nothing but PL by AE. AE. So AE here is coming stress L by E. This formula always you remember. This formula always remember na, it will be easy for you to understand. So we know this part. So we calculated this, we got the relations. Again, load on the steel rod equal to load on the copper rod. It will be the total load. And that way we can get the answer. So okay. So watch the video students from till to end, and share this video to your friend and subscribe the channel. Till now those not subscribe the channel. And listen here. One thing what will be there, no, this subject belongs to mechanical engineering department. So now if you will study the any other branch also, you will feel the easy to study the mechanical branch, all the problems and all. So if you have little concentrations, you can easily pass the mechanical branch papers and all. And now if you will scope wise, if you will see now, mechanical branch scope will be very good in this comparison to other branch, because other branch having lot of rush, lot of peoples are there. So now if you will, some parents and students are asking, sir, which branch will consider? So if you will select in present conditions mechanical branch, that will be very useful for you people. Okay. So here also lot of software things, artificial intelligence and machine learning, robotics, if you will AR, VR technology, e-vehicle, robotics, all those new things came in mechanical department, and huge demand is there in the market. So think and decide and join the branch. Okay. Okay, students. Thank you.